Our topic for today is HVAC fundamentals, heating, ventilations, and air conditioning. But first, we are going to discuss the cycle of refrigeration. The refrigeration cycle has four major components. Number one, the compressor, which is the heart of the system, is a pump that pressurizes the refrigerant. Number two, condenser, facilitate the heat transfer. Number three, expansion valve regulates the flow of refrigerant going to the evaporator. And number four, evaporator receive the liquid refrigerant. We have two components that separate the low pressure and high pressure side, the compressor and the metering device. The refrigerant came into the compressor with low temperature, low pressure vapor, and it comes out of the compressor as high temperature, high pressure vapor refrigerant. As it enter into the condenser, it start rejecting heat. As it rejects heat, it starts into saturated state where vapor and liquid exist at the same time. And it continues to reject heat until a complete liquid. As a complete liquid, it is called subcooling until it comes to the condenser. And it goes into liquid receiver, commonly known as pressure vessel, designed to hold excess refrigerant. Then through the filter dryer. The job of the filter dryer is to absorb any moisture in the system. The metering device or expansion valve, number 3, is the dividing point between the high pressure and low pressure sides of the system and is designed to maintain a specific rate of flow of refrigerant into the low side of the system. And then the refrigerant moves to the evaporator, which absorbs heat from the outside air and changes the liquid back to gas. At a cooler temperature and lower pressure, the gas is now at perfect temperature to cool your home. As it circulates through the enclosed space, it moves back to the compressor, where the entire cycle is repeated. Our topic for today, why AC rated in tons, not in kilowatt or horsepower. Air conditioning provides cooling to home by removing heat from air. This heat is measured in BTU or British Thermal Unit and is a measurement of thermal energy. It was first used in the late 1800s and has since become one of the most common units of classifications in heating and cooling appliance. 1 BTU is the energy needed to heat or cool 1 pound of water and 1 degree Fahrenheit at sea level. A ton of refrigerant is a unit of power used to describe the heat extraction capacity of air conditioning and refrigeration equipment. It is defined as the heat of fusion absorbed by melting 1 short ton of pure ice at 0 degrees Celsius or 32 degrees Fahrenheit and 22 hours. Now let's proceed to conversion from ton to horsepower. Note, 1 ton is equals to 4.714 horsepower. For example, in this case, we have 5 tons equals 4.714 horsepower divided by 1 ton. So we're going to cancel the tons. So the answer is 23.25 horsepower. This is equals to 5 tons. Next, how to convert ton to watts. Our example here is 5 tons. Note, 1 ton is equals 3.516 kilowatt or 3,516 watts. 5 tons equals 3,516 watts over 1 ton. So we're going to cancel the tons, 17,580 watts or 17.5 kilowatt. Next, how to convert kilowatt to horsepower. Our example here is 15 kilowatt. Kilowatt is the unit of electric power. And horsepower is a unit of power equal to 550 foot-pounds per second or 745.7 watts. Given 1 horsepower is equals 746 watts, 1 kilowatt is equals 1,000 joules per second. Answer, 15,000 watts times 1 horsepower over 746 watts. We are going to cancel the watts. So it should be 15,000 divided by 746. 15,000 divided by 746 equals 20 horsepower. Here in this example, we have an example of Lennox air conditioning. To know your tonnage, divide this number by 12. 12 stands for 12,000 BTU. So 30 divided by 12 equals 2.5 tons. So this nameplate is 2.5 tons. If your AC is 5 tons, it should be 60 here. 60 divided by 12 equals 5 tons. Our next topic is model number identification. 10 AHA is the type. AH stands for air handling. For U stands for upflow. D stands for downflow. The next letter is V. V stands for variable speed. The next one is 24. 24 stands for tonnage. In our previous discussion, we are just going to divide the 24 by 12 in order to get the actual tonnage. So in this case, 24 divided by 12 is equals 2 tons. The next is 230 is voltages. 230 volts single phase. If this one is 460, that means it's a 3 phase. The next is 2 or phase. If it is 3, bleed for Endor, TXV. TXV stands for thermostatic expansion valve. The next letter is T, is techno code. Hello, good morning. I have a problem with my AC today, and you know this thermostat, there's no power. So I'm going to give you a little tip or something like you will learn if you have problem with your AC in the future. So what I'm going to do, I'm going to pull this thermostat so that we can check inside. The red is the 24 volts supply DC, and the C is for common for the 24 volts. The yellow is for the compressor, and the green is for the fan. So I don't have voltage on my thermostat. I'm gonna check if plus my positive 24 volts with respect to compressor. So I'm going to go downstairs to check the controller downstairs.
Repeat.
What I'm going to do now, I'm going to bypass the switch so that I can troubleshoot what's going on. So just be very careful when you're doing this one, because we have 124 volts in the system. So what I'm going to do now is I'm going to check if I have output 24 volts from my controller board. So if you look here, I don't have a 24 volts output. So I'm going to remove this one to troubleshoot. Pause mo muna. I'm going to check now if the fuses is okay. So this is the fuses. So I'm going to remove this one and see if the fuses is good. So what I'm going to do now, I'm going to check the fuse if the fuses is good. So I found out that the fuses is born out. So if you look here,
So it's bad. So what I'm going to do, I'm going to replace this fuse, and let's see what's going on. I bought a fuse from AutoZone, so I'm going to put it now, and let's see what's going to happen. Now, if you look here, our thermostat has a power now, and I'm going to check outside if the condenser is running. Now you can hear that the condenser outside of my house is running now. So the problem is the fuse, and I will observe it.
HVAC values and multipliers. The atmospheric pressure at sea level is 14.696 psia, or pressure per square inch absolute. 1 psi equals 2.31 feet of water. 1 foot of water equals 0.33 psi. 1 ton of cooling is 288,000 BTU per 24 hours, also equals to 12,000 BTU per hour and 200 BTU per minute. 1 kilowatt equals 3415 BTU per hour. 10 kilowatt, 34,121 BTU per hour. 746 watts equals 1 horsepower. 1 therm equals 100,000 BTU. 8.33 pounds per gallons of water. 1 cubic foot of water equals 7.48 gallons. 1 cubic foot of water equals 62.4 pounds. 1 pound equals 7,000 grains. 8,760 in 1 year. 0.24 specific heat of air. 0.75 pounds per cubic foot density of standard air. 13.33 cubic feet per pound specific volume of standard air. 29.92 inches of mercury standard sea level of air pressure. 25,400 microns per inch. Length, 1 meter equals 100 centimeter. 1 kilometer equals 1,000 meter. 1 inch equals 2.54 centimeter. 1 meter equals 39.37 inches. 1 miles equals 5,280 feet. 1 meter equals 100 centimeter, also equals to 1,000 millimeter. 1 kilometer, 1,000 meter. 1 kilogram, 1,000 grams. 1 newton, 10 to the 5th dynes. 1 joules equals 10 to the 7 ergs. The atmospheric pressure at sea level is 14.696 psia, or pressure per inch absolute. 1 psi equals 2.31 feet of water. 1 foot of water equals 0.33 psi. HVAC terminology. If LA means full load amperes, LRA means lock rotor amperes, FPM feet per minute, CPM cubic per minute, GPM gallon per minute, WG water gauge, HWS hot water supply, HWR hot water return, BHP brake horsepower, CS condenser supply, CR condenser return, NP-HP nameplate horsepower, TDH total dynamic head, NP-SH net positive suction head, RE return and exhaust, OA outside air, SA supply air, RA return air, EA exhaust air, SAT supply air temperature, MAT mixed air temperature, OAT outside air temperature, PF power factor, SF service factor, SSH static suction head, STH static total head, SVH static velocity head, SST saturated suction temperature, SDT saturated discharge temperature, Hg mercury, Q quantity, V velocity, A. Area. TP. Total pressure. SP. Static pressure. VP. Velocity pressure. MBH. Thousands of BTU per hour. WB. Wet bulb temperature. DB. Dry bulb temperature. RH. Relative humidity. DP. Dew point temperatures. kW. Kilowatts. W. Watts. I. Amperage or current. TD. Temperature difference. Delta T. Change in temperature or temperature difference. EFF stands for efficiency. PF. Power factor, service factor, and static suction head.